Properties of logarithms. All right, so properties of logarithms. That's today's topic. They're a little bit different. You got to get used to them. Definitely practice as much as you can with it. And if you want to go look up like some other videos just to see problems worked out, then that'd be really cool. These are actually going to get used for other stuff is the key thing. So we're going to do some practice with them today. And at the very end of this, the last example is going to give you a very quick snapshot of how you do get to use these for much more important things. So here's the good news. There are only 3 properties. That's it. There's no fourth one. We're not going to come back to this stuff later and say, oh, by the way, there's one more thing. Now, technically, there is something that's called the change of base formula, which sometimes gets wrapped up in these, but it's not really the same thing. So these are our 3 big properties. Now, unfortunately, we're not going to actually get to, because of the way we were teaching the classes now, we're not going to get to break down why these work. That would be something that I would normally do in a class setting because I can answer questions as I go through it and really make sure that you understand the logic of it. So again, maybe watch some videos if you want to understand where these come from, but for us, we just need to be able to apply them. All right, so here's the deal. Number 1, everything that you see here, the base is always the same. So it doesn't matter if it's base 10, base E, so you can do this with natural logs, but you can't be changing bases within a problem. You can't have a 5 there and then like a 2 in this spot. Like all that's garbage. You can't do it. There's absolutely no way you can work the problem. So you can trust that as we do all of our problems, that these bases will be the same. But I do feel it was necessary to at least mention it. Okay, here's what the first property says. If you have a logarithm of some base, and inside of that logarithm are 2 things that are being multiplied or something that can be interpreted as 2 items being multiplied, you can actually split those items up into 2 different logarithms. Okay, so if we have the log base b of m times n, that is actually the same thing as log base m plus log base, or I might have said that wrong, log base b of m plus log base b of n. Okay, now make sure that you do pick up on this. What was multiplication inside the logarithm is actually going to be addition between the 2 of them. Okay, so this does 2 things for us. Again, that description, why multiplying and why adding, that's what we don't get to cover in this kind of distance learning thing. Okay. So it does 2 things for us. 1, you can either use it to split a logarithm up, or you can go the other way. You can actually take 2 logarithms that are being added together and just create 1. And there isn't like you should be doing one way or the other. It actually just gives you options in how you approach doing problems. All right, the next one, this one's called, so that was called the product property. This one's going to be called the quotient property. If you have 2 things that are being divided or something that you can interpret as a quotient, you can split it into 2 logarithms, but you're going to use subtraction. Whatever is the numerator part is going to be the first one, and you'll be subtracting the denominator part. All right, and then our third property, this one's called the exponent property. No, it's not. It's called the power property. It's been a while since I've done these. This one is called the power property. Okay, now that k is inside of the logarithm here. It's in the logarithm, it's m to the k power. Okay, and if you have that, you can take that k value and you can move it to the front and it becomes a coefficient. So it just ends up being a regular number that gets multiplied by log base b of m. All right, so for examples 1 and 2, what we're going to do is practice what would be called expansion. What we want to do is take this single logarithm that has all of this stuff inside of it and separate it as much as we can. What we want within the logarithms at the end will be just an m or just an n. Okay, and yes, this is going to become a bigger looking expression, so it's kind of the opposite of what you're used to doing, which is trying to simplify. We're actually going to be expanding it out. All right, so here's something that's super important. That 2 is applied directly to the n. It's n being squared, not the m. Now, if these were both in parentheses, then the 2 would be applied to both of them. So since it's only applied to the n, your first step in separating all of this is going to be breaking up the m times n. So we got log base b of m. That will be separated from the n squared part. We're going to do that with addition. And it looks like that. So multiplication becomes addition. Now that 2, we don't want that in the logarithm. That's just the game we're playing here. So what we're going to do is take that exponent using our power rule, or power property, we're going to call it, and then move the 2 to the front. So this is going to be our final answer. We're going to have log base b of m plus 2 log base b of n. Okay, that's what we want. Now, at the beginning of that, I mentioned that it's important that we understood that the n is being squared, not the mn. If both of these were being squared, like if we had parentheses around the mn and then there was the 2, your very first step would be moving that 2 to the front of this whole thing. And you would get an answer that would be a 2, and in parentheses, log base b of m plus log base b of n. Hopefully you can visualize that. I don't want to have to write it down, but little subtle differences can totally change how you approach it. All right, example 2 is going to do a little bit of that because the radical can be reinterpreted as a power. All right, think about that for a second. The square root of anything is the same as raising to what power? The 1/2 power. So everything is raised to the 1/2 power. So 1/2 is going to go to the front at the very beginning, and then everything else is going to be in parentheses. Okay, now for the sake of not needing to, or not wanting to write this over and over again, because there's a lot of logarithms, I'm just going to talk through like the steps. Within here, that cubed is only applied to the n, which is like what we had going on there. Okay, so we're going to split first with the subtraction. We know that we're going to break this apart using subtraction. The m cubed is going to be in the front part. But remember that its own exponent is going to move to the front. Eventually, I just don't want to do all the steps. Okay, so the log base b m cubed is going to sit in the front as a 3 times log base b of m. The subtraction is going to be log base b of n, that part. Now you may need to do these in like step by step, but it's one of those things that I know how to do it and I can visualize the steps. So I don't want to write it like 5 different lines for like to do that and have all this inside of it and then to split and then to move to the 3. All right, so example 3 is going to be the opposite of what we were doing. We are not looking to expand things, we're actually looking to condense them down. Notice these both just say log, no subscript. So that means that these are actually the common log, which is log base 10. It doesn't do anything in the problem. You just need to know that they both have like a 10 that would have been there. So then our rules can apply. All right, so we're trying to get everything consolidated. Before we can do any of the subtraction, that 2's got to get moved out of the way. Okay, and the easy move in that one is make it an exponent. Okay, so we'll have log of 45 minus the log, and let's see here, 3 squared, 3 to the 2nd power is going to be a 9. And I think it'll be helpful to see that right now because of what the next step's going to tell us. To completely pull these together now, that subtraction, go back to the properties here, that subtraction will become division. You got to be careful that you don't do subtraction become subtraction. This is division. We got log 45 over 9, which, yeah, conveniently is log of 5. And yes, you can type these in the calculator, and why don't I do it for you? All right, type that in here. I don't even have to type bases. All right, log 45, we're going to subtract 2 log of 3, and gives you that number, right? But what we need to see is whether it's the same thing as log of 5. So log 5, there you are, exactly the same thing. I suppose you couldn't test that out with the m's and the n's, but any of these number value things, you can plug values in, you can check them out. All right, let me go back to one point. It's very important that we get the connection between multiplying and adding. We also get the comparison or the connection between the division and the subtraction, because you want to be careful that once you get to this point, you just don't say 45 minus 9, which will give you 36, because it's not the same thing as log 36. That's totally different. So there is it's a change in the operations. Once you get used to it, you get it. All right, example 4. This is going to be a snapshot of how you were able to use these properties for some actual value. Okay, but it's not totally there yet. All right, what we do have is an equation. We got an equation here, and you're asked to solve it. That means you're being asked, what is x? Right there. But we have 2 logarithms. We have 2 logarithms here. And each of those logarithms has an x in them. And one of the general ideas about solving for a variable is to make sure you've had it in one spot. So the only way that we're going to get these x's together is to apply our product rule. See, we got 2 logarithms, both of base 2, that are being added together. So I can make a single logarithm if I multiply these together, which that's somewhat easy distribution. So I'll just go ahead and write that in. Okay, so x and the x minus 2 multiply to give you x squared minus 2x. Okay, and that is equal to 3. Oh, and as a little side note, because I've done this many times, just as a little caution, once you multiply those 2 things, you can't just drop out the logarithm. What we're doing is this combining of the logarithms. So we still have a log base 2, and that is important for the rest of the problem here. Because next, you can't just set that equal to 3. This is all within the logarithm. Next, what we're going to do is go back to the definition of logarithms, and we're going to change this into an exponential, because we don't know how to actually do things with logarithms. It's the best answer to it. We don't really know. So I'm going to take out the logarithm, use that base 2, but raise it to the 3rd power, and set that equal to everything that was in the logarithm. So if you do need to go back and review the definition of logarithms of last week, that would make sense, but it's cover and switch, and you get that. Now look at that, 2 to the 3rd power is 8. What I like about that step is it really puts emphasis that this base is important. In all the other problems before this, it didn't matter what the base was as long as the base was the same thing. But here it's actually part of the problem, because it does get raised to the 3rd power to give you 8. Now, we reevaluate what we've got. This is actually a quadratic. So this is not about isolating and solving anymore. It's about factoring. So let's see. Multiplies to give you -8, adds to give you -2 is going to be x minus 4 and x plus 2. So from that, look at this, quadratics. They never go away. Never. They're going to be there forever. Okay, answers that we get will be 4 and -2. We get 2 answers. But not really. You don't. Because we talked about graphing previously. And we talked about the domain of graphing. And generally speaking, a logarithm has an asymptote at the y-axis and goes in this direction. Now there's variations of them, and when we graphed them we had transformations, but for any logarithm, no matter what the base is, one thing that holds true is that you've got this vertical asymptote, and there's numbers that don't work for it. So without any shifting in a graph, the boundary is at 0. In other words, you have to have x values that are greater than 0. You can't put 0 in there, and you can't put any negatives. If I put that number in, go back to the very beginning, it doesn't work for that logarithm. Now, and sometimes you might end up adding on to that number, and then it actually becomes positive, but it fails right here. You put it in there and you've got a negative number, you type it in, it's not gonna work. Put it in that spot, it actually gets even worse, right? You get a -4, so that doesn't work. But a +4 will stay positive in both of these areas, and that will work out to be the answer. Let me see if I can type that guy in. I'll turn it on first. What was base 2? We believe the answer to be 4 plus 2. It's gonna be a 4 minus 2. Could just put 2 in there, but all right. See if we get a 3. And you get a 3. Try that with -2. Yep. Well, that altogether that'd be -4 anyway, so just -4. And don't make sense because it doesn't fit the domain. So at the end of any of these solving problems, and we're gonna do more of these in the next set of notes. This is just a little bit of a preview of it, but if you start with a logarithmic equation, make sure that your answers don't create any negatives inside, right? Even like if I had the answer of a 1, a positive 1, that would be no good because right here you get -1. So you do need to go back. Don't just look at that and say, oh, negative, take it out. You got to go back and you do need to see how they work in the actual equation.